Hello and welcome to Let's Code an Indie Game episode 4. This is the series where I take people through the tools and techniques needed to get started with independent game development. Right, what are we going to do in this episode? We're going to look at introducing a new class to manage Gamestate. So at the moment, while we only have 2 entities in the code, we don't really need to worry too much about what's going on, but eventually when we have a lot of entities, hundreds of objects all floating around, we're going to need a way of controlling and managing that. So let's get started. Right, quick review of where we got up to last time. So let's start by just running the game, and we'll see last time we were looking at movement strategies, how we can have different entities with different sort of movement behaviors. We swapped, I think at the end of the last episode, we swapped some code around, so we were moving the slime and the player was just bouncing up and down. So let's quickly change that back. So if you remember, in our entity class we added a new argument which was the type of movement we wanted to use, and for our slime we want to use bouncing movement, and for our player we want to use keyboard movement. There we go, we're now moving our player and our slime is just gently bouncing up and down in the breeze there. Very good, very good. Let's quickly take a look at how that code worked. Just remind ourselves, or remind me. So inside of Logic AI movement, we have 2 different strategies for moving our entities around. We have the keyboard strategy, which hasn't really changed. We just moved where it lived. And we have the bouncing strategy, and this is where we introduced the concept of a z-axis as well for moving up and down, although on our screen we can only move in the 2 x and y positions. If you need a recap, you can always go back to episode 3, where we talked about this in more detail. Okay, so let's think about what we're going to do today. So if we want to add a new entity to the game of moment, we have to do this. Let's just go for it. So let's make slime2 entity create. We can use the slime sprite. Let's put this guy at 150, 300, z of 0, speed of 3, and again we'll make him bounce. Just run the game. Oh, of course, we also need to remember to, and this is kind of good because we're going to do something to make this easier anyway, but at the moment we have to remember to update and to draw for every new entity we add. So that's calling the slime update method and the slime draw method in our love draw and love update functions. So now if we run the game, we can see we have 2 slimes bouncing up and down in unison. But if we want to add a third one, we can go in and type out the code to add a third one, but it's going to get very difficult to manage very quickly, especially when we want lots of things on the screen. So we're going to introduce a class to manage a lot of this for us. So the general running and housekeeping of our game. So let's go over to our logic folder, new file, and we're going to call this Gamestate.lua. And as always, we'll start by making an empty table and returning that table from our module. So now we have something we can hang functions off of. So straight away, let's do a Gamestate create, and this is a function. And again, as should be familiar by now, let's make a new table and return it, and this is going to be the instance of our Gamestate class. Now we're probably only ever going to want one Gamestate at a time, but I'm still modeling it like a class here just because I think it's nicer, it seems to fit in with what we're doing. We can always change it later, but for now it feels like it's something we want to create at the start of the game and then just get rid of at the end of the game, or if we want to reset or anything like that, which is why we're modeling it as a class with instances rather than just a module or a bunch of functions. Cool, so we are going to create 2 methods on this guy straight away. The first one is going to be called add entity. Oops. There we go, equals function. And this is going to take self because it's going to be an instance method, and it's also going to take the entity we want to add. And so if on our instance of the game state we add in another empty table called entities, now up here we can use table.insert, which is a method from the Lua core library, and it's used for, unsurprisingly, inserting things into tables. So here we can, first argument is our table, which will be self.entities. Second argument is the entity we want to add. There we go. And the second method we are going to add here is update. Like many of our classes, like our entities class, this is going to have an update method. But in the update method of the game state, what we are going to do is we're going to say for, we're going to put in an underscore here because we're actually going to ignore the first variable passed to our for loop. The second variable, though, we'll say entity. So for ignored and entity in, and we're going to use ipairs, self.entities. And what ipairs does is it will take a table, and for every value in that table, it will give it a number, which is the order you're going through the table in, and it will give you the thing from the table itself, the entry in the table. So we're ignoring the number. That's why we've put in the underscore. That's just a convention to sort of tell us later on that we're ignoring it. But we're going to use the entity. So for every entity in our list of entities, we want to do, what do we want to do? We want to call entity update. So rather than having to go through and manually call update on every single entity, this class should do it for us as long as we've used the add entity method as well. So let's just wire these guys up. So instance add entity is going to equal our add entity method, and instance update is going to equal our update method. So let's make use of this to tidy up our main class a bit. So we can go ahead and pull it in. Gamestate equals require source.gamestate. We'll make a variable called game to keep it in, and so the first thing we're going to do in love.load now, so when our game starts up, the first thing we want to do is do game equals gamestate.create. Now at the bottom of our load method, after we've created everything else, we can go ahead and do game add entity, and we can add in player, and we can also add in slime and slime 2. Then in our love.update method, all we should have to do is call game update. Let's see if that works first time. Nope, so source.gamestate not found. Fair enough. That's because gamestate lives inside of logic, so we can fix that nice and easily. Source.logic.gamestate. Try again. Attempt to index up value game a nil value, and that's coming from main.lua line 22. So game equals gamestate.create, but here add entity, and add entity is coming up blank. Let's just check out our game state quickly. Of course, we need to return the instance of our game state there. Bit of a typo, going a bit too fast. Okay, bad argument number 1 to insert. Table expected got nil. And this is in add entity. self.entities. So it is claiming that our self.entities table at this point is nil rather than new value. So let's just check. Yep, typo. Aha! And here we are. We can still move around, we can still bounce, but the important difference is after a few sort of typos there, we now just have to call game update instead of updating everything else. And we can do the same thing for drawing. So let's go ahead and add in a draw method to our game state as well. So unless something goes horribly wrong in these episodes, I like to leave in the bits where things go wrong because I think it's more real. That's what programming is. It's making a small change and then going back and fixing all of the stuff you didn't realize that you'd broken. And then doing it again and doing it again. So really the smaller the change you make, the better, because there's less stuff to go through when something does go wrong. But that's how you learn. Making mistakes is perfectly fine. So again, we are just going to use our for loop here and the iPairs iterator on our entities, loop through all of them, and this time we're going to call entity draw. Let's make sure we wire it up. So just attach it to our instance down here, save, and then in our main .lua file, we should just be able to go ahead and do game draw. Give that a bit of a save and run, and here we go. So we have exactly the same, exactly the same scene is going on. We can still move, our slimes are still there and bouncing up and down, but this time we don't have to worry about remembering to call draw for every single entity. Our game just takes care of it as long as we've called add entity and added it to our game loop. Right, so what are we going to do next? Well, the other purpose of having this game sort of object to manage the state, or this game class, is we can start to use it so that our entities can interact with each other. Because at the moment when we call... If we look at our bounce method, perhaps, as a good example, there's no good way at the moment of getting hold of anything else that's going on in the game. The entity can only affect itself. But, if it's a game, we want the entities to be able to know what's going on. We want them to be able to interact, because that interaction between different systems and different ideas, that's what makes games interesting. So, what we can start to do is, in our update method, pass in the game state, or we'll just call it game here, as the second argument. So let's go ahead and do that. And let's actually do something with that game state. What shall we do? Right, in our game state, we're going to change it slightly so that when we create it, we actually pass in the player. And this is because we want to treat the player differently to all of the other entities in the game. And we are going to just store that reference to the player in the game state at the moment. So instance.player equals player. Very good. And we just need to remember now in our draw method, let's make it the last thing we do actually, is going to be self.player draw, and in our update method, self.player update. Very good, and then we need to remember to make changes to this file as well. So when we create our game state, we want to pass in the player, so let's move the code that creates the player above creating the game state, so we've got something we can actually reference. Just to fix the indentation quickly. There we go. And we no longer need to add the player as an entity because it is treated differently. It's a bit special. So let's just run that, see what happens. Excellent, everything still works. We can still move our player around. Everything still gets drawn. But now we've done that, we have an easy way of actually getting hold of our player reference. So if we go back to bounce.lua, we can now say local player equals game.player. So what can we do with this? Well, let's make our slimes bounce higher if the player is next to them. So let's create a new function here. Let's make sure it's local. And we'll call it bounce height. And bounce height is going to take the entity that is bouncing and the game. So let's move the code that pulls out the player from the game into bounce height, because that's where we're going to be using it. And so we can get the distance between our player and our entity. So we're going to do this the quick way for now, and in a later episode we're going to look at distances and 2D mathematics around how you move things and calculate distances in more detail. But for now, let's just very quickly say, let's say player x equals player.x and player y equals player.y, and then we will say dx, which will be the difference between the entity x and the player x. So let's go ahead and do player x minus entity.x, and let's go ahead and do the same thing for our y value, player y minus entity.y. And then if we employ a bit of mathematics, we can get the length. So this will be the math.square root. Thank you. Nope, just math.square root. So the distance between 2 points, if people remember their mathematics, is dx squared plus dy squared, all square rooted. So good old Pythagoras. A squared equals b squared plus c squared. So let's make sure we assign this to something. Distance is the square root of x squared plus y squared. And then let's just say if distance is less than 100, then return, let's return 400, else we'll return our current bounce value, which is 200, end. So this function probably will not live for very long. It's really just here to illustrate illustrate how this works, but let's go ahead and use it. So down here we can say if x is greater than bounce height, and we pass in the entity and the game. Let's give it a run. Okay, closing bracket expected near comma on bounce line 3. So let's just, of course, bounce height equals function. Very important. Okay, and attempt to index local game a nil value. So this is because we're not passing our game into our update function yet. So let's go ahead and do that inside of Gamestate. So every time we call update, we're just going to pass self into the update function. And this will mean that anything inside of our entity has access to that game function. So now we just extend the update method on entity to also take the game, and we pass that straight into the movement as well. So we're just threading it through the needle all the way through. Now let's run again. Attempt to perform arithmetic on global dx a nil value. So why is dx nil? That's because I've used capitals. So again, typo, save that. So let's move our player closer to our slimes and see if they... there we go. So one slime is bouncing higher. Let's move to the other one. And the other one is bouncing higher. Cool. So there we have a quick demo of how we can make objects interact with each other. Or entities, rather. How we can make entities interact with each other. So finally, let's make things a bit more interesting. So down here we can say for, and we can use a different form of Lure's for loop here. So we can just, if we want to iterate between two numbers, so we'll just say for I equals 1 all the way to, let's do, I don't know, 32, then end, and down here we can do local slime equals entity.create, and we're going to want our slime sprite. We are going to want to pull out a, let's just call it random x is going to be math.random, and here we can pass in love.graphics.getWidth, and random y equals math. So math.random just returns graphics.getHeight. Math.random will, if you give it, there's a couple of different ways you can call it. If you pass in a single number to math.random, it will return a random number between 1 and the number you've passed in. So random x will be a random value on our x coordinate, but within the screen. Random y will be a random value on our y coordinate within the screen. And then our slime is going to use that random x, random y value here. Z value is going to be 0, so we start on the ground. Let's go for a speed of 4, just because they were looking a little slow, and our movement strategy is going to be bounce. So now we can get rid of those two lines. We'll hang on to our slime sprite because we're still using it. And finally, inside of our loop, we are going to do game add entity slime, and we'll get rid of these two calls to add entity here. So now we should, if everything works, be creating 32 slimes in random locations on the screen. Let's go ahead and see if that works. Oops, do expected near then, line 19. So we want do here rather than then on the for loop. So for I equals 1 to 32, do all of this stuff. Here we go. And if we move our player around, we can actually make the slimes bounce up and down two different heights based on where our player is. Excellent. It's kind of hypnotic looking at it. Very good. Cool, so let's finish the episode there. That was a quick example of how we can make objects interact with each other. Hope that was useful to you. As always, if you like the video or want to subscribe, that would be great. If you want to give me some feedback, how can I make this more interesting, or how can I target the things you guys have questions about, very happy to receive it. Thank you very much, and goodbye.